everything is perfectly normal. There's no reason to panic. We have a camera crew because, like many college campuses, there's sort of an instructional development department here that can help new faculty members and old faculty members improve their teaching. And so I thought if we had, this kind of thing where they record you, you go in and you watch yourself and you're like, oh my gosh, I make these rookie mistakes. And then they say, yeah, we'll try to get better about that. So don't panic. They're going to be here for about 25 minutes and then they'll get out. And life will return to complete normal. But yeah, thanks very much for being here today. As that sort of brings me to the first point, which is that you've probably been spammed about this student ratings of teaching thing. I talked to the person who sends those emails out. She's like, I don't send them out. Tell them I don't send them out. It's automated. Like, apparently you guys get a lot of, like for every class you get reminded over and over about this. So I want to encourage you to do rate me and rate the class because because I'm hopefully young and have many students who will I'll teach later. Any sort of feedback you have will pay dividends to those students as well. So you're also welcome. I'm always unsure about whether or not to do this, but there's also, of course, as you know, ratemyprofessor.com, which is a little more open and public. So it's always a little more dicey for a professor to suggest doing that. But I welcome your suggestions. So cool. Okay, so we're just going to jump right into exceptions. Exceptions are a framework that Java has of managing failures in your code when inevitably there will be some sort of problem with some code. And today we're going to talk about how the interfaces that Java has to recover from those failures. So I guess the first thing from sort of a philosophical standpoint is a discussion of sort of types of failures. How can a program go wrong? I guess the most fundamental thing is an error could happen. This is what Java calls an error. Some sort of event has occurred that is outside of your program's control. So for instance, a hardware failure. Say you've got your scanner open, you're reading lines out of a text file. That text file, unfortunately, was on a flash drive that has been plugged into the computer. And as your program is reading lines, somebody yanks out the USB drive out of the computer. That would result in the operating system essentially, your program would go to get next int or whatever, get next int, and the operating system would bubble up an error saying, hey, bad news, this entire file doesn't even exist anymore. The whole file system doesn't even exist anymore. You ripped out the whole file system thumb drive. And that's something that your program could not anticipate and should not have to deal with. Essentially, if that happens, the correct thing for your program to do is crash because something severe has happened. There's another, outside of apocalyptic hardware problems and out of your control things, there are a couple other ways that things can go wrong. One is, and they're both called exceptions. An exception is sort of just a shortening of the word exceptional event. So a couple of exceptional events that might happen. They sort of fall into two categories. Things that you should be able, where your program should be able to continue running, should deal with and continue running, maybe not flawlessly, but it should not totally barf, and things where that indicate that there has been some sort of bug in your code or bug in your API, and your program actually should quit and give you, as developers, the most information as you can so that you can find the bug or the problem. And so a checked exception is a kind of a failure where your program should be able to recover at runtime. So for instance, maybe you have a program where the user specifies a file, or in your code you have hard-coded, you all did this on the exam, you've hard-coded a text file that your program is going to read, and what happens if the file doesn't exist? Well, if it's the kind of thing where the user is meant to provide a file name that the program will analyze, maybe you should reprompt the user. If you sort of hard-coded the file name, well, okay, maybe it doesn't matter. I mean, for the purposes of the kinds of problems that we're doing in this class, where it's just like a homework problem, the program crashes or not, it doesn't really matter. Like, it doesn't. Maybe you don't need to be so fastidious about trying to catch that error. But if you were writing some sort of production code where your program really does not need to just barf all over the place, like a web server. A web server is a program that runs in some server closet, in a computer in some server closet, and it's never supposed to quit. If it's supposed to sit there and wait for computers to connect to it and ask for, I want google.html, I want some HTML file to download, and if it ever quits, the webmaster gets a call at 3 in the morning that says, why is this web page down? And so when you're writing a web server, almost all exceptions should be accounted for and recoverable. It's a little bit hard from your perspective because all the programs that we've been writing are short, relatively short programs that don't need to run no matter what. So anyway, that's the first category. The second category is a runtime exception. These are problems that maybe you should not recover from because they're an indication that there is actually some sort of logical problem in your code. So for instance, if the client passes a null pointer, like maybe we initialized or you declare some sort of object, but then you forget to say new, bank account or whatever. So this reference, this object reference, bank account B is just a null pointer because you haven't allocated any memory for it, and you pass that, or you try to call bank account.balance or something, you get a null pointer exception. This is a sign of a bug in your program, and you would actually like your program to crash in some way that is informative so that you can find that bug. So those are sort of the three types of problems this is the way that Java has arranged how they philosophically approach the kinds of failures that can happen in your code. So, oh yeah, and one last thing is you've probably seen, we've all had to do this thing where, the compiler won't make my program because I need throws IO exception in main or something at the top, right? We've all been bothered by that before, and today we're going to learn why you have to write that and why you don't have to say something like throws null pointer exception. Even though we write programs that throw null pointers exceptions by accident, how come I don't have to say that it throws a null pointer exception? Actually, the answer is right here. Null pointer exceptions are a type of runtime exception. The compiler can't tell whether or not your program is going to throw a null pointer exception or not. That kind of checking is too hard. And so null pointer exceptions are a type of runtime exception. Whereas being able to deal with the absence of a file that you were expecting is the kind of thing that you should be able to recover from. So IO exceptions are here, and null pointer exceptions are down here. Here's sort of a graphical interpretation of this. So there's this class, this built-in class to Java called throwable, and there are two essentially main subclasses of throwable: errors, which are the sort of the hardware things that you cannot deal with, and these are unchecked by the compiler in the sense that the compiler will not make you deal with a hardware error, and exceptions, which for the most part are checked. The compiler will make sure that you are dealing with the exceptions that come up, with the exception of runtime exceptions. So errors, exceptions, and runtime exceptions are the things that we were just seeing on the previous slide. And descendants, subclasses of error, include things like, are you out of memory? Is there some sort of fundamental operating system problem that is going to crash your program? Subclasses of exception include things like IO exception, other sort of problems that you should deal with. And subclasses of runtime exception are things like null pointer exceptions, arithmetic exceptions, and so on. Here, in fact, is a better list of this. So you've got your errors on this side, you're out of memory, there's a stack overflow, really fundamental operating system problems. And then under exceptions, you have runtime exceptions, like, oh, here's one that we've all hit, index out of bounds exception. So this is like, you've tried to get some character of the string, you've tried to get character 20 out of a 10-character string. It's not going to happen. An array, a subclass of this is what happens if the thing that you're indexing into is an array. So there's lots of ways that you can index into something. Strings have indices, even though they're not arrays. If you're dealing with an array, that will give you a little bit more information. If you get an array index out of bounds exception, then you know that the problem that you hit was indexing into specifically an array, not just a string or any other generically indexable object. What are some other kinds of runtime exceptions that you can hit? An illegal argument exception if you've given the wrong kind of argument to some function. Okay, so these are all things that you need to that you cannot tell if that's going to happen ahead of time. And on the other hand, here's IO exception. This is one that we've all hit. And there's a lot of different ways that you can have an input-output exception in your code. You could have look for a file that doesn't exist on disk that the operating system can't find. You could have a socket exception, like you are communicating over a network with another computer, and that happens over a socket. So a socket is essentially like a file that, except instead of writing it to disk on your computer, it writes those bytes outside, out of the network, out of your network card to some other computer. What happens if that network suddenly goes down? Well, your program maybe shouldn't crash. Maybe a socket going down is not the same as like a catastrophic hardware error. Maybe you should try to reestablish the connection with the computer. Okay, so these are the types of things that you should be able to check for and recover from, and these are the types of things that the compiler will not require that you deal with. Okay, so let's just talk about the syntax for how these things work. Here's an example where it's a class called myFile0. It just has one main method. It's going to try to divide 42 by 0 and print out the result. And if you try to, and it's going to do this by calling this a divide method, which is right here. It takes an int x and y and returns the ratio. And if you do this, obviously you would get some sort of arithmetic exception. So your program would try to execute this line. It would fail. It would raise an exception. You have not programmed anything in here to try to deal with that. And so you wouldn't even get to this print line here. Your whole program would crash on this line. So that's sort of where we're starting from. Here's a better way to do it. Here's a way that deals with that exception, that at least detects it. I'm going to make the divide function. So I'm going to make a variable for the thing that I'm going to assign the ratio to. And here's the new syntax, try. Try and catch. Those are two new words that we haven't seen before. I'm going to try to perform this division here. I'm going to try to essentially do this, do these lines of code. And if that works, that's great. I will just jump over this catch block and go directly to return z. Otherwise, something bad might happen here. And if something bad happens, I would like to maybe deal with it. I'm going to catch an exception that may be thrown, that may occur during the course of evaluating this line. And specifically what I'm looking for, if you remember on the previous slide, the type of exception that was raised by this method failing was an arithmetic exception. So I would like to catch an arithmetic exception. I want to call that, and this is the part E. This E here means I would like to, in the body of this catch block, in other words, between the two curly braces here and here, I would like to be able to refer to this exception. So an exception is a class, right? And so when a new exception gets thrown, essentially what's getting passed around is an object of that exception class that has baked into it all of the interesting information about where was I in this part of the code. I started here, I started here. This is information called a stack trace. So when you have methods that are calling other methods, that information is stored in what's called a stack. And a stack trace is essentially just an object that keeps track of, that has stored in it, you were at this line, then you called this function and went to this line, and so on. So with a stack trace, you have a nice sort of diary, a nice little, you can do a black box in an airplane. You can do a post-mortem analysis of how your program failed. And so this exception object here is of type arithmetic exception. And inside this E, which we'll see in a second, this is an arithmetic expression, an arithmetic exception object, and it has methods like print stack trace. And that's essentially what gets printed out by default when your code fails. It just prints out a stack trace. There was essentially only, here's the stack trace. You were at the problem hit at this line here on line 7. That's where this happens. And how did we get to line 7? Well, I got there from the main method. I went from main into divide, and the main method called divide on line 3 here. So here's a very short stack trace that explains how you got to this deplorable situation of having this arithmetic expression error. And so, okay, so that's what this E is doing here. This is an object that you can use to explore the stack when you have some sort of problem. And so if you catch that arithmetic expression, that arithmetic exception, you can then execute this code here. So if there is an arithmetic exception while you're trying to execute this line, this will execute this code here. And this is very nice because you can actually print out things like, hey, how did I get to this state? Oh, I was trying to divide 42 by 0, sad face. Once this catch block finishes executing, at that point you get to decide things like, well, should I quit? Should I return something? Here, nothing happens. You could do things like, I want to just abort the entire program. I want to just kill everything because this kind of error is so bad that I need to catch this kind of bug and debug it and not try to continue with the program. In this case, I just said, instead of saying things like, return like something awful or break, or terminate the program, I just decided to, in either case, if this works or I catch an error, in either case I'm going to return Z. So I prints out the error message, returns the nan, which it was initialized at, and you can even see that the program continues to execute. This line afterwards gets executed. Are there any questions on this? Sean?
Yeah, instead of error, could you replace it with how the same thing?
Totally. In fact, I'm doing this in Sublime Text, and it doesn't even do like the coloring. Normally, like system.error would be colored red, so that you could see the error more easily. It's more alarming to your eye. But my text editor that I'm running this in doesn't even differentiate between system.error and system.out. Yeah, absolutely. Cool. So let me give you another example. this is from your book. I figured maybe it would be good to have some examples that you could go and study later. Here they essentially put up a dialog box that asks for an integer. And if you put it, and then it essentially, and this dialog box, because it doesn't know exactly what you're going to put in, returns a string, which is whatever you put in. And you can print out that string fine, nobody gets hurt. But if you try to parse that parse that string as an integer, something bad might happen. Maybe you didn't put in something that can be parsed as an integer. If I put ASDF here, then this will fail. Then the program will fail. It'll say, you entered ASDF, but of course, as soon as it tries to parse that as an integer, you'll get a number format exception. OK, let's see how you might write this program in a way that doesn't just barf and terminate the program. So do the same thing as before. Grab an integer, print it out, and now we will try to parse that string as an integer. And if that and once we do that, we will say conversion was successful. And if this all worked, we will jump past this catch block down to the bottom, where we will just say n is, and then we'll print out the integer that we parsed. If during the execution of this try block, we encounter some sort of a number format exception, which we will refer to in the body of this catch block as NFE, this variable. We can call this thing whatever we want. Then we will print out a bunch of debugging information. So NFE, this exception has all exceptions have methods getMessage, which we'll see in a second what it does, toString, and print stack trace. And these methods are all available to you for helping debug your programs. And so let's see what it does. So let's see. I guess, let's see. We put in an ASDF. It yells at us. So that's this line here. Sorry, incomplete data. It prints out getMessage. And so this is the message that was generated by the built-in number format exception when we failed to parse that integer. And if you want to know not just the message, but who generated the message, that's what toString spits out. And then if you say print stack trace, that will barf all this stuff out here. But the important thing, this looks exactly like how you would fail normally, but the most crucial point is that afterwards, your code can continue executing. That's this line here. So this gives you a lot more control over how your program fails and tries to recover from that failure. And you probably, so any questions on the mechanics here? Yeah.
Just a really silly question. What's the backslash n?
Oh, this?
Yeah.
Yeah, this means a new line.
Oh.
Yep, backslash n. Yeah, so this is a little bit screwy here. I wish they hadn't put the backslash n there. They could have put in another print line call above it just to put in some more new lines. But yeah, the backslash n and then the n is confusing. Yep.
Gotcha.
Yeah. Other questions on the mechanics of this? Yes, please.
So ASDF was entered.
Yep.
And I'm just trying to understand the last line.
This one here?
Yeah.
Yeah. This gets set to 0 because it is initialized to 0 up here. And if we had parsed it correctly, it would have been set to something else. And then down at the bottom, but because it wasn't parsed correctly, this essentially failed. A bunch of stuff was printed out, and then n was printed out at the end. Yeah, exactly. OK. And so you probably remember from when we were doing like scanner stuff that there is we did things where like I made you in your util class, you wrote methods to grab an integer or a double or whatever, and it was the kind of thing where you would continue to pester the user until the user provided an integer or a double or whatever. So the user could say ASDF, 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 and your program would keep saying, nope, sorry, not an integer, try again. And let's see how that would work in this scenario, because here we're pretty much dealing with a similar thing, except you'll notice here nobody is using the hasNextInt method, which is what you used when you were trying to test to see whether the next token was interpretable as an integer. So let's see how that works. Instead of doing the hasNextInt, they're essentially catching the exception and trying to deal with it. And so here's how that works. So this all looks the same as before. We're going to grab some string, try to interpret it as an integer, and if that fails, we're going to yell at the user, But all of this try-catch block is wrapped in a do-while loop. So we will do this. We're going to try to interpret it as an integer, and if it fails, if it works, then we'll set the good input to true. And otherwise, we will just prompt the user again and grab another string. While we don't have good input, we're going to essentially repeat this loop. So this looks a lot like the code that you had before with the has next int and everything, except we're just doing something a little bit differently. We're just using the try-catch block to actually essentially let the parseInt method intentionally fail, throw an exception, and then use that as our criteria for looping again. I don't think one of these is necessarily good or better or worse than the other. It all sort of depends on what your application is. It's just sort of an example of something that you've seen before with a little twist. OK. So there's this one last keyword, which is finally. And here's most of this stuff we'll talk through, but I want to point out the new keyword is this finally block here. So let's see what this program is doing. There's a method called writeList. It essentially, let's see, there's a try block that is going to try to do some stuff. The try block ends here. And what it's going to try to do is essentially open up some file and then print some stuff into the file. And this uses classes called file writer and print writer that we'll talk about later. But essentially, it's a mechanism for writing files. For I equals 0 to some constant, some big number, then we will print out essentially the element of some list. So some of these variables here have been defined higher up, and I'm not. Anybody think of any sort of errors that might occur that we might need to deal with in the execution of this code? Just this code right here. What sorts of things might go wrong? Even though we haven't seen these classes before. Please.
An out of bounds exception.
Where?
When your list.getI.
Yeah. Yeah. I mean, we're going over this thing. We didn't do anything clever like this enhanced for loop or whatever. We're just going up to this size. Hopefully the size is like less than the length of the list. Otherwise, we'll get an out of bounds exception. What else? Renee?
You might not be able to write the file.
Yeah, something might go wrong here. Like maybe the file doesn't exist. Maybe the file is locked. Maybe there's some sort of abstruse file system problem where the operating system just essentially boils up an error saying, sorry, for some reason, I'm not going to be able to let you write to this file here. Yeah, so those are essentially the two kinds of errors that kind of jump out at you for what might happen. And they are explicitly caught in two different catch blocks. You can have as many catch blocks.